Do you have a question, Max? I'll have to lower the volume. You'll have to unmute to ask your questions.
How are you doing, Jim?
All right. My boss, Darth Vader, stepped away so I could help you work on your homework. Efren, you asked, how is our final going to work? We are not having a final. You must get your homework done during the last week of class. You'll have to unmute yourself if you want to ask a question, Efren. Well, does anybody have any questions about the sapling homework? Why don't we work on a couple problems from the sapling homework? Just a normal day doing homework. I will share my screen. Would you like to work on homework number 2 on sapling? I've had a request to work on this. I'm just asking if it is still a request. Hello? Yes, I will record the lecture. Max, I'm not sure why you don't hear me. Juan, does somebody hear me? Okay. Let's work on this problem. Grab it. I'm going to paste it into whiteboard. I'm going to share this whiteboard. Please click on it. You will have to unmute yourself if you have a question. All right. Go ahead and read the problem. Okay, here we go. A 250K lump of clay is dropped from a height of 1.45 meters onto the floor. It sticks to the floor and does not bounce. What is the magnitude of the impulse imparted to the clay by the floor during the impact? Assume the acceleration due to gravity is 9.81 meters per second squared. Apparently, this must be the Earth, not Tatooine or the forest moon of Endor. All right. To find the impulse, we need to find the area under the curve. I'm going to enlarge this. Anyone want to help me find the area under the curve? Yes. To get the impulse, you have to get force delta T. Which in this case, the impulse is just the area under this curve. What shape is that? It's a triangle, and as Max has stated, it is 1/2 the base, which is 9.5 milliseconds, which is 10 to the negative third seconds, times the force. Since we are not given a value for the force, we have to figure that out. The only way you're allowed to find the force is if you use the dark side, by the way. Little joke there. The other way to find the impulse is that it is equal to the change in momentum. So that is equal to mass times velocity final minus mass times the initial velocity. The final velocity is 0. So the total change in this impulse in this case is negative mvi. But note that since the object is moving down a piece of clay, it will have a negative velocity vector just before hitting the ground. Which makes sense because the impulse is positive. When it hits the ground will produce a force upward, which will be positive. Any questions so far? Find the initial velocity right before hitting the ground. We have to use energy. A piece of clay dropped from a height with an initial velocity with a velocity of 0 in the beginning, and then right before it hit the ground, it had that velocity right here. It started with a height h, So the initial pie chart is all potential energy. And the final pie chart is all kinetic energy. So the initial energy is equal to the final energy. The potential energy due to gravity is equal to the final kinetic energy, or the kinetic energy right before impact. Which is mgh equals 1/2 mv squared. And this is actually the initial velocity here. M's cancel out, and the initial velocity is going to be equal to 2gh square root. Any questions so far? Does anybody have any questions so far? Please respond. Thank you, Harold. Everybody else is not at their post. Now we're going to use this initial velocity to get the impulse. Since we said the j vector, which is the impulse, is equal to negative m times negative vi. That's equal to m times the square root of 2gh, which is the total impulse. Once we have that, to get the max force, we have earlier solved it for here. One half the base times the height. In order to solve this, solve for F max. Multiply both sides by 2, divide by both sides by the change in time. This is the second part. And just to remind everybody, this is problem number 2 off of homework 7. Which I will label up here. Make sure everybody uses the link I gave them at the beginning of this. Is there any more homework questions? Cecilio asked about one of the energy problems. I could give you a really quick run over the energy problem here. If that's what you'd like. Let me grab this. And there was also another part to it. All right, let's do this. The diagram shows two carts of mass A and B that are initially held together with a string. This includes the plunger, which is the spring, with the spring constant K, that are initially compressed to distance x. They are not moving in the beginning. Later, the spring breaks, and the plungers push a cart from each other. In the end, cart A is moving to the left with the speed VA, and cart B is moving to the right with the speed VB. Assume the surface is frictionless and the system is composed of the two carts. All right. So we have to do the momentum. In the beginning, neither cart was moving. Therefore, they will have no momentum one way or the other. And since they don't have any initial impulse, but since this is much like an inelastic collision, two carts were not moving in the beginning, and in the end, the impulse, the momentum of each cart will be opposing each other. Object A will be moving to the left, so it will have a negative momentum. And I'm going to just say that they will have an equal momentum. So object B will be moving to the right, therefore it will have a positive momentum. Notice that the initial momentum is equal to 0. And that is equal to the final momentum, which is a negative 2 blocks and a positive 2 blocks. Does that make sense to you, Cecilio? Cecilio, you have a question? Cecilio, are you going to respond? Apparently the rebels have taken Cecilio. Do other people want me to continue doing this problem, or should I stop it? Okay. Now, let us go with the energy part. Well, we will finish up the equation for the momentum. So, the reason why the impulse is 0 in this case is because the forces are equal and opposite. And since the impulse has to take the entire system, which is both objects A and B, a positive force will be negated by a negative force. Therefore, the total impulse is 0. And that's the reason why you have only momentum in this part. So now we will set the initial momentum equal to the final momentum. The initial momentum is 0. The final momentum is going to be the mass of cart A minus the velocity of cart A plus the mass of cart B times the velocity of cart B. Notice that I put the negative VA for cart A's velocity after the explosion, much like the Death Star, where I lost a lot of friends. Anyways, after that moment of silence, let us begin with the energy part. With this one, I would like to talk first about the kinetic energy. After the impact, they will both have positive kinetic energy. Since kinetic energy is 1/2 mv squared, this must be a positive value. Does that make sense to everyone?
Why is the initial momentum 0?
Because initially they were not moving.
Thanks.
Yes. Just when you think about momentum, think only of velocity and mass.
Thank you very much.
You're very welcome. Now, the beginning energy was all bound up in the spring. Max, I'm trying to read your question. The vector looks like it's moving. I thought VO was the same as VI. Yes, they are. I suppose it might have been moving in the beginning. Let's reevaluate this. Thank you, Max. I really wish you had typed that earlier, Max. All right. It says both objects were moving to the right initially, from what it looks like. So that means they both have a positive momentum initially to the right. After the explosion, it may be something more like this. Where it is now 3 blocks. Does that make sense?
Yes, now it makes sense.
Thank you very much. All right. Before the impact, I think I need to add more energy. Before the impact, both objects had a kinetic energy. And they have a momentum, they will have a kinetic energy. And they both had 1 block of each. I'm going to say the spring also had energy as well, since they were bound by the spring. Now we must apply the conservation of energy. Both of these are the same velocity here. This is the energy of the spring that causes the explosion. This is equal to 1/2 ma VA squared plus 1/2 mv v squared. This velocity is the same as this speed. This velocity its magnitude is the same as this speed. Thank you for your assistance. This was 4.2. Are there any more questions about this? I hear my boss coming. Every time he gets close, this music seems to play. It's very strange.
Could you go back to that question, please? I want to check something.
This question,
Yes.
in a sense, it is about it seems he's passed by. I think we're safe. Did not label these final velocities. You could subscript these. Little f, just to clarify this. Yes. My boss, Darth Vader, seems to have passed by.
Well, thank you very much. I already checked.
Okay. Does anybody have any other questions? We will have another WebEx tomorrow at 11 a.m. We will have WebExes next week. Tomorrow is not mandatory, Jorge. We will have another on Wednesday as well. Well, thank you, everyone. Everybody have a good week. I will see you tomorrow at 11 and also Wednesday at 11. I don't know this gym person. I'm TK426. Thank you, Efren. Max, my name is TK426. Thank you. Goodbye, everyone.